Hey, I just wanted to show you what I got working with the TV. Um, I kind of gave up on messing around with different methods, and I'm just going to use the candy edge detector like I've been using. Um, I did make it adjustable so you could adjust the kernel size for the blur and also the gradient Sobel kernel, but I fixed the synchronization issue where the lane detector would publish the output image and then the map server would take that, combine it with the latest position vector and stamp it on the map. Well, now the lane detector directly publishes a point cloud instead, and these are floating point values, and they're actually ROS coordinates to the master coordinate frame. So, and I can also I'm managing the timestamps now so that those points are timestamped the same as the image is timestamped. So basically, that's made the mapping part of this work almost perfectly. I mean, it is perfect for the most part. Um, let's see here. We don't actually need a map server. Um, what you can do is you can, and it doesn't ever explain this in any of the online stuff, but under your cost maps package, when you launch this, you can, so for like your global cost map, you can specify its width meters, height, resolution, but then you can set observation sources like right now I got a laser scan, which would be our LiDAR, and then this point cloud, which is our lane points. So it'll start with it being cleared, and it'll mark. So you can set it to mark the map or clear the map. Right now, everything it's like a trap door. Everything's just marked. And so now I don't have to even have a map server at all, which is nice. The less of my code, the better. Um, Run this. I also added this sweet little thing over here, so it overlays the camera image in the actual rendered 3D scene for RViz. Uh, I had to just all I had to do is create a TF point for where the camera is, and so that lines up exactly with what's going on in RViz, which makes everything nice. Run the mission. You can see that I mean it lines up perfectly, and so we can use this to manually adjust those sliders to whatever our real perspective winds up being. And you'll see that these points come through on point pretty much. Oh God, that was lame. So yeah, I mean that's fixed that almost 100%. Now we are still using ideal odometry here, but I mean compared to what it was before, which was this image, you see how way out of whack it was, and it was like spewing crap all over the place. I gotta do this because it always likes to get stuck right there. Come on. Oh well. But at least you can see how it's working as far as the how the lanes come through. Still working on the actual mission controller navigation, but I don't know why I get stuck right there. Been working fine all day. There it goes. That's funky. But yeah, I had to slow it down quite a bit. So it's running at 0.7 meters per second right now. But let me go ahead and kill this. Yeah, ignore that. It's going to show you, this is the output. So I also wrote a little note that will save the global cost map that it maps. So this is the result of a run that I did. And I don't know if you remember what they looked like before, but this is way better. There's still a little bit of ghosting, but compared to before, I mean, it's literally like nothing. Um, but yeah, it looks good now. So the actual perspective mapping part has been solved 100%. So it just comes down to uh, how well the actual lane detector works in terms of actually outputting only the lanes in the grass and not anything else. So that's the only other question there. But I mean, I'm done with computer vision, man. I'm so done. Oh my God, I'm so done. It's good enough for me. But appreciate y'all for watching, checking it out. Peace.